Okay, on the computer and also on the backup USB is manuals. On the computer, they're located in the C drive in Documents, and then a folder LDR Motion Systems, and then Manuals. Within that, there is Air, Electronics, Part Picks with labels, Setup, Operating, and Software. So Air gives us our Air schematic. Electronics is all the electronics we're using, switches, power supplies, servo motors, and then also an electronic schematic of the entire machine. Part picks with labels. Just shows you a picture, and we have everything labeled as to what we refer to it as. Setup and operating. Alignment procedure, which these should not, alignment procedure and setup should not have to be done. We've done it. It's more of something happens in the future. We rebuild your headstock for you. There are some things you're going to have to adjust and check. Must do steps. That's the bare minimum you have to do to actually cut apart. Axis directions. It's all in here. Software. We use a lot of custom macros. This explains every macro and what it does and when it's used. Inputs and outputs. What the inputs are, how they're wired, what port and pin they go to. Same thing with outputs, what relay number that is on the relay board, what it goes to, what output number it is in the software, and the port and pin. And then different variables that can be entered on the screen. I will show you in the video. So this is all located on the computer and also on the backup USB drive. Alright, so let's start with generating some code to actually cut. So we're going to start up our CAM program. This is the screen you're going to come to. First thing you want to do is you go here, and we're going to either manually, conversationally generate some code, or we're going to import a 3D model. So we have two different options here of round or box section. So I'm going to do a simple box section program and show you the flow of work and where it goes, where the file goes, and how you generate it. So we're going to do a box section, and I want to cut this out of 3 by 3, an 1/8 inch wall. I've measured my radius. Typically, your radius is double your wall thickness. However, we do find you will get a slightly better cut, especially on a cutoff, if you actually measure your radius. And for us anyway, we many times find that the radius is slightly smaller on the thinner tube than twice the wall thickness. So I have it entered here as 0.235. And then how long this part needs to be. So let's say it's 18 inches. Choose OK. That has generated our tube. Okay, so we now have a model of our tube. Okay, so now you can actually describe what you want in any order. You don't have to work from one end to the other. You could put holes in it first. So let's put a hole in the center of that. Let's do a round hole. It is 1.5 inches round. So now we've defined our hole. Now we tell it where we want to position it. Well, we can position it from the left end, first end, or the right end. So I'm going to choose from the left end. And I'm going to say that I want that to be 9 inches because I want it in the center. Now we can offset it from the center. At the current moment, it's centered both left because I put it in right because I put 9 inches, and then across the tube. So I could put an off center of 3/8 of an inch. Or I can just leave it in the center and leave it at 0. Angle. If I put something like 45 degree, you will see that it is going to allow me to put a 1.5 inch pin through here. We can get a 1.5 inch, yes. 1.5 inch hole, but it's going to cut an oval so that it'll fit in at 45 degree angle. Now we can rotate that about to the tube. So we could actually even rotate that at a 45, and it's going to put it right on the corner. I'm going to leave that at 0. Alright, so I click up, next thing is pattern. You can have multiple of these. How many do you want? The distance in between them. How many rows? You can do a rotational pattern. You can also tell it that you want it to be through hole or just a single hole. Right, so I'm going to do a through hole. So I click apply, and then OK. And now we can rotate this around and see that I'm going to be able to slide a 1.5-inch rod at a 45 degree through there. So now I want to miter both ends. So I'm going to pick my first one, and I'm going to miter it at a 45. Apply. Pick my second one. I'm also going to miter it at a 45, but I want to rotate it 90 degrees to the first miter. I click apply. And OK. So there we have our part. Once we have our part, we can unroll. Alright, so here's our path that we're going to create. Okay, so this is what all of the programming is based on. Now we need to give this a name. You first pick your customer name. So everything works saving G-code as the customer name and then a contract and then an actual file name. So got Westcott here as the customer. The contract is just test. We're just test cutting. I'm going to give it a name that's useful. This will actually tell you the material. So this is 3 by 3 1/8-inch wall, and the length is 18 inches. This is fine, except for if you do another one, you have a chance of overwriting this. So most people like to actually name them something that's appropriate for their, cross beam there. 3 by 3. You do need the .tcs extension to be left on there. So I choose OK. Alright, now I want to come down here to actually generate my code. So that saved our drawing. If you wanted to do more 3 by 3s, you could go right in here and just keep generating all the drawings you need or importing them. So now when I go here, I can select my customer. So I've got my customer there. The contract, I only have one to test. And my material. You'll see that I have two different materials because I've generated two different programs, one prior to this video and then this one. So what am I cutting? Well, I'm cutting 3 by 3. I only have one 3 by 3 part or file, and that's the one I just generated crossbeam. If you had gone back and you had generated 16 different 3 by 3 parts, they'll all show up here. And you can either select all or select none, and then you put the quantity of how many of those you want in here. In this particular case, we only have one drawing. I'm just going to do a quantity of 1. Choose nest, and voila. There's my nesting report, and there's the G-code. That's it. It's all done. If I wanted 2 of those, I would put 2 of those and click nesting. If I wanted 2 of those, 1 of the next file, 7 of the next file, 8 of the next, click nest, it generates the code for that. Up here is where we pick our power source. We only load the plasma cutter that is actually sold with the machine. If you change plasma cutters to a different size, let me know and I will get you a custom database with your power source listed in there. So that's a simple way of generating code. It's very quick. We can go right back to here again. We could do another one. This particular one is 24 inches long. Okay. And all I want to do is miter the first end at a 22 degree angle. So I click apply, OK. I can unroll it. I need to save it. To do 3 by 3 by 24, 1 miter. That's what I will call it. Which is OK. I come in here. You'll notice that when I pick the material, I now have 2 different files. 2 different files that can be cut out of that material. I have multiple files, but of course you can't nest multiple things together on different materials. So now I could go here and I could say I want to do 1 of those and 4 of these. And there is the G-code generated for that particular program. So you can rerun this G-code, or you can easily just come back into the program at a later date if you need a different quantity. Don't even use the drawing part, go directly to the nesting program, put your stuff in, and create a whole new file.